Hey, welcome back to Algebra 2 Easy. Let's talk about the factor theorem. In this problem, we've been given a function, and your job is to figure out, is x minus 2 a factor? We can use synthetic division to figure this out, and this is a helpful way to solve when you aren't allowed to use a calculator. What you're going to do first is take your possible factor, x minus 2, and set that equal to 0, and you're going to solve for x. So I get x equals 2. When you're setting up your synthetic division, you're going to put that x value, so 2 here, is going to go outside the synthetic division box. Across the top, inside the box, are all the coefficients of your function. So we're going to go in descending order, and always a good idea to check to make sure you're not missing any terms. I have x cubed, x squared, x, and then a constant. If I was missing a term, I would want to replace that with 0. In this case, we're not missing any terms, so I can go ahead and list those coefficients. And I'm going to draw a vertical line right here at the end. This bottom right-hand corner represents your remainder. Because this is a process of division, we might have a remainder, and that's going to be really important to us. So let's go ahead and use synthetic division here and see what we get. The first term, you're going to drop below the line. Any number below the line is going to get multiplied by that x value outside the box. So 1 times 2 is 2, and I'm going to list that underneath my next coefficient. Now, we're going to add from here. 4 plus 2 gives me 6, and then I can multiply the 6 by the 2 outside the box, and I get 12. And now we can add the negative 4 and the 12 to get 8. And again, if it's a number below the box here, we're going to multiply it by the 2. That gives me positive 16. And if I add negative 16 with positive 16, I get a remainder of 0. Because I have a remainder of 0, that tells me that x minus 2 is a factor. That is the factor theorem. If you use synthetic division and your remainder is 0, then that value represents a factor of the polynomial. If you get any number other than 0, then x minus 2 would not be a factor. But again, because our remainder was 0, we have determined that x minus 2 is a factor of this function. I hope this helps, and be sure to follow us for more.